Hi there, Year 9s. There's a question for exercise 1G to do question 8 and 9. 1G is to do with distance and midpoints. So in this question, I'm going to do 8 and then see how long it takes to do 8 before I do 9. Question 8. If I were to do question 8, it says the distance between the 2 points. So you got -2, -1, and the other one is A3. They tell you the distance is root 20. So you know the distance is equal to the square root of 20. They want you to find the values of A and use a Cartesian plane to illustrate why there are two solutions for A. All right, well, let's draw a quick Cartesian plane over here just to visualize what might happen. So, that's a -2, -1, so -2, -1. So you've got a point here, that's -2, -1. And then you got A3. So we know the y value is 3, but A could be anywhere. So we don't know where A is. So A could be here, that could be A, or A here, A here, A here. All of these coordinates could be A3. So we just don't know where. So it could be from here to here, it could be from here to here, from here to here. But the difference is that each distance, the further I go out, so let's say I went all the way out here, A3, that distance is much longer than these other ones that I just picked. So it means that why is there only two possibilities where A3 can be equal? Well, the logic to it, if you just look at a diagram, let's say A was over here. Let's just say A is here, hypothetically. All right. Then this line, okay, there must be another point where the distance between this point and this point is exactly the same, but still remains on this y value of 3, because we need the y value to be 3, right? So hopefully we know with the, what's it called, isosceles triangles, we know that for them to have two sides the same, there must be another point somewhere else over here where the distance is exactly equal and A is obviously much more negative, and yet the y value is still 3. So it's still on this line y equals 3, but clearly there must be 2 points, only two possible points, where the distance of the yellow line and the blue line are exactly the same. Okay, that's the logic. So I expect one to be bigger than the other. That's what it is. So we now do the calculation. So we go find the coordinates of this point. So let's do it. We know the distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared. And we know the distance is root 20. Whilst this is the square root of, now x1, let's just call this x1 and y1, and let's call this x2 and y2, doesn't matter which one is which. And so what I would get then is x1 is a minus -2 all squared plus y2, which is 3, minus a -1 all squared, right? I'm just going to zoom in a bit here. So then from here, this is the square root of 20 is equal to the root of, now you've got a plus 2 squared plus 3 plus 1 is 4, 4 squared is 16. All right, and what we can see is that, well, inside, both of them are square roots. And inside of them, well, remember, both left side and right side is meant to equal, so that means what's inside must also be equivalent. So you can say, therefore, or you can square both sides if you want. But I can say, therefore, 20 must equal to a plus 2 squared plus 16. And the way I taught it in class, do inverse operations. Don't expand the brackets, because if you do that, it makes it more complicated. So minus 16 on both sides. And then you get 4 is equal to a plus 2 squared. And to get rid of the square, so essentially you're saying something squared gives you 4. Now, the logic is that square of what will give you 4? Well, we know that the answer could either be 2 or -2, yeah? And so that means that a plus 2 could either equal to 2 or a plus 2 could equal to -2, right? Because that's the only way to get the answer of 4. And then you can solve the equation here. You can see that a will equal to 0 or a is equal to -4. So obviously there's 2 points, which goes back to my idea before, is that A could be at 0 And so you had 0, 3. So this line here should be equivalent to the other line, which is -4, -3. So -4, 3. So -4, 3. These two lines must be equivalent as an isosceles triangle, which kind of makes sense. If you think about it, it's 2 units across to get to 0, and then 2 units across to get -4, and the height is exactly the same. So it is an isosceles triangle there. And that's the logic there. But let's say in this step here, I jumped the gun here before. If you didn't want to do it intuitively here, what you could have done is from this step, you could have done inverse operations, and you could have said square root both sides. And we then get square root of square is cancelled out. A plus 2 is equal to, now root of 4, remember it's not just 2, there's a plus or minus 2. So when you square root a number, there's 2 possibilities because square root is the opposite of squaring, and we can see that 2 or -2 can get you to 4, so that means when you square root 4, it could be either 2 or -2. Okay? And there you go. So if you have a plus 2 is equal to positive or -2, then therefore subtracting 2 on both sides, you either get a is equal to -2 plus or minus 2, and that's how you get 2 answers. -2 plus 2 will give you 0, and the other version is -2 minus 2 gives you -4. Cool? That's how you would do that problem there. So visually you can see why this occurs, why there would be 2 possible answers to get a distance of root 20. All right, that would be question 8. I'm going to finish this video and then I'll do question 9 next.